my internship project, an EV ADAS dashboard system built during my internship at Emertxe. So first, let me explain you brief about my project, what I have done in this project through this slide which I have made. So first, let me go to this PPT and I will explain line by line in very brief. So yeah. So what is my project is EV ADAS dashboard, electric vehicles advanced drivers assistance systems, and the dashboard which is I am showing all the data from the hardware sensor which I have used, potentiometer and ultrasonic sensor. I will tell you later, and then we show all this data in the Python dashboard. So first I have used, in short, let me tell you, I have used the blue pill boards and then Pixim Lab for simulations, our datas, and then ultrasonic sensors and Python. Uh, the library which I have used to show the dashboard is matplotlib. So the problem, why smart EV dashboard matters. So the problem which is modern EV generates huge volume of a real-time sensor data, but we cannot able to get the data very like in a very with a accurate and all that, like speed, battery, SOCs, motor temperature, torque, and range. All these data go waste in the modern EVs, and without a centralized dashboard, engineer cannot monitor EV performance and ADAS safety data simultaneously. So and the single operator cannot track everything manually, right? So collisions, blind spot, and fault may go undetected. So what I have implemented in my project to solve this problem is EV ADAS dashboard system. First is real-time speed data, SOC, and range monitoring, and second thing is ADAS collisions and blind spot detections. Blind spots basically left and right distance blind spot, and the motor temperatures and fault alerting. If the temperature goes above the 90 degrees Celsius, we just give the alarms, which is a fault, and everything just stop. So this is what happened in the motor temperature, and then live Python dashboard via UART. We are also showing the live Python dashboard with the help like via UART communications, and then we tired alarm system. We also implement the alarms like advisory to criticals, and then drive mode. We also show the drive mode eco, normal, and sports. So this is the why smart EV dashboard matters. This is the reason. So now system, this is my system architecture of my project. So first what we are doing here is we are taking the input from the we are taking the input from the two sensor, which is we are generally I am only using a two sensor, ultrasonic sensor and potentiometer. This potentiometers, acceleration pedal, brake pedal, batteries, and motor temperature, all this data is analog, so we have to convert this analog data into the ADC data. After converting into the digital data, we get this parameter calculation with the physics formula, inertias, and all that. Generally, like we are using physics formula. With the help of physics formula, we are calculating the speed, torque, SOC, range, and drive mode. After getting the EV control, it is basically a code. It's not something like, it's just a code written, EV controls, and then here is ADAS control. So what is EV and ADAS? So electric vehicles, in EV there is a parameters. The parameters is speed, torque, SOC, range, and drive mode. But in ADAS is advanced driver assistance system, means we are implementing a collisions and all that. If the EV cars get so close to the any obstacle, it will it will alert the it will give us alert. So yeah, this is written in the ADAS controls, and after integrating both the modules, we are implementing fault and alarms. If it's a fault, if it's a collisions fault and all, if it's a collision fault or it's because of a motor temperature is becoming greater than 90 degrees Celsius threshold, which I have said during this in my project, then it's also considered to be a fault. So this is a like everything basically written in the code. So yeah, fault, and then we are passing through the UART at this speed 11 lakh 50 to 1 lakh 15,200 baud. So yeah, now let's move. This is my phase of my project. First, development environment, and in this project I have learned a lot of things. Like, let me tell you in brief what I have learned during this project. It's kind of a learning project. Learning, what I have learned is STM32, how to set up the STM32 cube ID, how to set up the Pixim Lab, what is Pixim Lab used for, then Python setup, and then GPIO peripherals, what is GPIO, how we set up this GPIO pins, LED buzzer and all that, and we convert the LED buzzers and ADC sensor inputs, which is potentiometers, and this is my ADC sensor, acceleration, brake, and motor temperature. All this calculated with the help of potentiometers. Like, all this data comes from the potentiometers. And then EV dynamics model, which is speed, torque, SOC range, and regenerative braking and drive modes. Regenerative braking means if we apply the brake, our battery get charged by braking. That's called regenerative braking. We're not wasting our brake. Like, brake helps to charge our battery. Then ultrasonic ADAS. This is my ultrasonic ADAS means we have three sensors, left, right, and front. Ultrasonic sensor. Left sensor detect the left distance if it's if our car gets close in the left side of the vehicles, or if there is any obstacle, alarm will trigger and tell us. It will tell us that it is a we have to be safe and all that. So this is all this. After that, fault and alarm system. We are this is our features of the project, and the UART telemetry, which is speed, SOC, torque, temperature, and range, and then UART shells, and then Python dashboard. So yeah, this is the whole thing, and let's move to the next slide. And this is my ultrasonic ADAS. This is my EV, and then left sensors, right sensors, and the front distance. All this measured by the ultrasonic sensors, and then according to that we will get the warning, right? If the front distance is less than 50 centimeter, we will get the warning, or if the front distance is less than 20 centimeter, we will get the warning. But it's not a warning, it's a critical warning. We will see in the demo, right? And then blind spot detections active. It will active when it's less than 30 centimeter or speed is greater than 20 kilometer per hour. Or time to collisions. Time to collisions warning is if the time to collision is less than 3 seconds, we get the warning. But if it's less than 1.5 seconds, we will get the critical warning. So this is the whole thing, all this. And then move to next, fault with. So yeah, fault detections, yeah, alarm. We will get the alarms when the things are not, like, if certain things are less than threshold, or whatever what code I have write in my code logic. According to that, fault detection started, and it will give us alarms. Like, it will basically 4 fault. I have implemented 5 fault OT, the motor temperature, then is fault SOC, and the fault collisions, fault sensor, and fault common timeouts. This is the fault which I have implemented. If alarm, this is the alarm, this is the fault, and this is the alarm. There are 4 alarms: alarm none, alarm advisory, alarm warning, and alarm criticals. It depends on what condition it is satisfying. So it will get triggered then. And this is my UART telemetry protocol. So first, EV telemetry frame. This is speed, SOC, torque, temperature, range, acceleration, brake. All this will calculated by the physics formulas, and all this data is come from the potentiometer sensors data. This is all the sensors data, potentiometer sensors data, and this is the ultrasonic sensors data: front distance, left distance, right distance, time to collisions, and uh, blind spot detections, and alarms, and then faults. And this is the same thing which I have explained to you. Then after this, all the EV parameters and ADAS parameter we all are showing to the dashboard. What we are showing to the dashboard is speedometer, batteries, and then speed history, EV matrix, and ADAS bird eye. There are these all things, 5 things which I am showing on my dashboard. I will show you in the demo. Do not worry about it. And then result and demo. So yeah, I will show you the demo. So this is the whole idea. Like, this is the whole idea which I have learned a lot of things during my internship, to how to set up everything and how to calculate, how we can use the sensor to really solve the real world problem, like EV and in EV electric vehicles, in the automotive electric vehicles domain and all that. So let me show you the demo. I have already, yeah. So this is my fixing lab, and I have already set up all this. So acceleration pedal, brake pedal, acceleration and brake pedal associate motor temperatures. If I increase the acceleration pedal, battery get this decrease. If I increase the brake pedal, my battery get charged. And yeah, right now I'm not getting any alarm because everything is good. So what I'm getting, front distance is 272. All this data is printing here, and this is the same data which I can show you. If I increase the motor temperature, I will get the alarm. Alarms. I will get the alarm. So this is the advisory alarms I'm getting, right? The fault one. This is all data we can directly see to. We can see to the here. Let me do this. Yeah, this is the already 103 kilometer per hour speed, and this is our batteries, 65.8%, torque is zeros, and acceleration is 47%. Motor temperature is so hit, let's just see it, and alarm is, but it is not exceeding 90 degrees, that's why it's not saying critical. And the faults, and this is our front distance 380, so there is no collisions right now. So if I let me change the parameters. First reset it, and then yeah, decrease this and increase this accelerations. Decrease this. Yeah, I'm getting the, if it's less than, if it's 30, I'm getting the red alarm. Okay, so let's see it. I'm getting both. Hold. Front distance is this. Speed is right now. Speed is increasing a little bit. So slowly speed get increased, and yeah, let me first reset it. Okay, yeah, it's speed's getting now get back to zero, and alarms is critical, right? So because I have set a speed not from the initials is zero, I'm not setting to 20s, and all threshold is already zero. So, and this is my code. This is my code which I have. This is my main project code, and this is my learning project, LED blink and all that. ADC test. So this is my main project code. So yeah, this is every dashboard, ADAS C, ADAS H, everything I have included. This is our ADAS parameters logic code. This is my main.h, and then main.c, everything is here. So this is my whole code, and this is my Python logic code, and yeah, this is the thing. And so yeah, if it's collisions because front distance is less than 30, that's why we are getting the alarm is criticals, and battery is 30%, and speed. Let me do this first. increase the speed and let me increase the acceleration. So this is the whole project, and now it is slowly increased because I've set the threshold which is increasing very slowly, that's why. So now there is no alarm. The alarm is getting none. So this is the whole project. I hope you understood my project, what I have did in this project, and I had a lot of learning during this my internship. And thank you for watching.